All right, we're going to try a new microphone tonight, so hopefully this comes in loud and clear. Polynomial equality, it's so easy. You just got to keep track of your negatives, and you got this. And then we're also going to do a little polynomial division, because what would life be without polynomial division? All right. Hey, so let's start. If you have something this straightforward, life's good. I've got some visuals for us. This is saying that A is equal to 1. This is saying that B is equal to -2. This is saying that C is equal to 3. And our good friend D is equal to 7. So it's all about everything in front of the x cubed on one side equals everything in front of the x cubed on the other. It's called comparing coefficients. Comparing coefficients. All right. That's awesome. Love when that just slides up. All right. So this is a doozy. I love this problem. I'm going to show you how I did it. So when I think about a problem that's got a little bit more on the right-hand side that makes it more interesting, all you have to do is multiply it out and then compare everything in front of each corresponding term. So when I have more than, one at a time, I'm going to multiply that x out. And then one at a time, I'm going to multiply that -2 out. Now, what I like to do is do each row and then stack the corresponding terms. So the first one obviously is x cubed, ax squared, and bx. So when I start with this 2 here, -2 times x squared is going to be 1 degree less. So I put it right below the x squared and I write those out. This plus c kind of hangs on at the end. So I'm ready for it, so I add those. I rewrite the polynomial on the left, and then I really pay attention and group everything that's in front of the x squared, x, and the constant term. So at this stage, let's see what I've written here. I write myself a note and say, look at all the x squareds. Well, the coefficient of x squared here is 2. So I write a 2 on this side. The coefficient of x squared on this side is -2 over it plus a. That tells me a equals 4. So I've already done with one of the variables. The coefficient of x, -3 over here. And so I write a -3 equals -2a plus b. I already know what a is. Plug it in. Hopefully add and subtract right. And I get my b value. And finally, the constant term on this side is a 4. The constant term on this side is everything without an x, or the coefficient of x to the 0. That's just lame, but sometimes they're going to ask you, what's the coefficient of x to the 0? What they're saying is, what's the constant term? Don't fall for it. All right, so they are that easy. So why in the world, Mr. Sayers, would I do another problem? Well, I just want to make sure you got this. So hopefully you can see where my 2z to the 4th plus bz cubed plus 3z squared. So I've taken this z squared and I've multiplied to that, and to that. So that gives me that one right there. All right. Well, so in that fashion, I'll just get that nice and clean. You can see that this row comes from multiplying that out to everything, and this row is that out to everything. I've stacked and made a nice, beautiful process. Life is good. I'll just go right there. You can trust me, I hope. Look at all those. Look at all those. So I know the coefficient of on the left side is 2, on the right side is 2. Did I need to write that? No, but I might as well act like I needed to write it, so I'll do a little check mark. Z cubed, now we're getting into it. We got a little bit of an equation going there. We got another little equation, and our constants, 6 and 6. What if those are different? There's no way to manipulate that. If we had 6 equal to 7 there, we'd just say, game over, this is not any fun, we're not doing this problem. All right. So the way I did this, and the way you communicate sometimes is you label the equations, 1, 2, 3, 4, 5, and then you tell the reader, gee, I wonder if we're going to write a paper at some point. Yeah, you tell the reader that I'm using equations 1 and 3. Now what I did is I just wrote equation 3 here, and here I multiplied equation 1 by negative 2. What for? Well, I'm all about that negative 2b, because when I combine those two equations, that goes away. I'm left with this. Negative 3, negative a equals 3. I'm going to plug that back in and get b. I'm going to make sure it satisfies equation 2, and it does. Life is good. Okay, so comparing coefficients. Multiply both sides out, compare each corresponding term, and you'll probably get a few little equations out of it. Nothing you can't handle. All right. So sometimes they reword it a little bit. They tell you that 2x plus 1 and x minus 2 are factors. What that means is they go into it evenly. So that times something will equal that polynomial. No remainders, nothing hanging on. But the question is, what is that? And man, I think it was Marissa. I was grilling her a little bit about, how do the degrees work? How do I work this? Degree 1. What would this have to be to get a degree 4? It'd be a quadratic. So get used to writing general polynomials, whether it's a quadratic, a cubic, so forth. What we think of as quadratic is ax squared plus bx plus c. But a and b have already taken. So you just got to bump those variables. I'm going to go cx squared plus dx plus c. We got the same problem. But maybe we can kind of hedge our bets a little bit and make it a little easier. This is my thought. I'm going to try to find C, D, and E first. Once I know C, D, and E, I'm going to go try to find A, B. And once I know A, B, then notice this is asking for all the zeros of Px. Well, we already know two factors. That means x equals negative 1/2 and x equal 2 are two zeros. I'll bet if we solve that quadratic equal to 0, life is good. We'd have all the zeros. You got to give yourself direction in math problems. So that's the direction I would take. I don't know if I did too much more on this page. Yeah. Notice the leading coefficient. So there's only one way to get an x to the 4th term. And that is if you multiply that 2x, that x, and wow, does that like to jump? And that cx squared. So I know that that times that times that is the only way I could get an x to the 4th term. I know the x to the 4th over there, so that tells me our good friend is c is equal to 1. D, I'm not too sure, but the constant. What is the only way I can multiply all those out and get the constant term? Well, it's just driving me crazy. Notice the constant. We have a 1, a negative 2, and e. So those are the last terms. Those are the only way that you're going to multiply the term times a term times a term and get a constant. So we know that e is negative 4. What I found is now D is a little bit weird. It's like, So I cleaned it up a little bit. This is what we know right now. This is what we know. Right there, we put the C in for 1 and the E for negative 4. Now we have to just multiply it all out. Well, how do you multiply something times something times something? Well, the easy way is multiply 2 of them first and get that. Now I'm going to do exactly the same process as before. In fact, I'm not even going to talk you through it. I'm going to talk a little bit. Multiply the 2x squared, and I got that. multiply the negative 3x, got that, and the negative 2, got that. I compared the coefficients for x cubed, x squared, and x. It turns out on the last one, D is really easy to solve for. Then I used that solution and it helped me find what B is, and then it helped me find what A was. All right, so mission accomplished. I got all my variables done. Now I'm going to look at that quadratic. It turns out that quadratic can be factored, and therefore my zeros are going to be from this, negative 1/2, from this, positive 2, 4, and negative 1. Easy peasy. So this is, I don't know if this one's on your homework or not, but isn't it the exact same? It's giving you a factor. It's telling you an x cubed, so it's baiting you. What should go here? And that problem is exactly like the problem we just did. Fill it with a quadratic, maybe look at the leading coefficient and the constant, and you got this. You got this. I believe in you. Polynomial division is such a pain. I hope you never have to do this. What if you did? It's so simple, but it's a pain. So let's just do it. There's a lot of P's and Q's and R's up there. Let's just kind of go through a quick example of what you guys are used to, or maybe you're not. It's been a long time. So 5 goes into 3. No. 5 goes into 32. Oh, 6 times. So we'd write a 6 there. 5 times 6 is 30. And then we subtract that, and we get 2, which is less than 5, so we're done. So there's some cool little notation. If you found it in a couple thousand years, you'd be like, wow, they are super advanced. What this is kind of saying right here is maybe how do you rewrite it? So if I wrote 32 over 5, this information right here is telling me that I can write it as the quotient, which is going to be the top number, 6, plus the remainder, 2, over the divisor, 5. Yeah, what for? Good question. But I think that's one way to write it. The better way to write it is I think there's a little gremlin in there that just makes this thing jump unless I do that. So I think a better way to write this is 32 can be rewritten. 32 can be rewritten as 6 times the divisor plus the remainder. Hey, the remainder being 2 is very cool. The reason that is it's not 0. So that means 5 does not go into 32 evenly. If it was 0, life's better. We love it when things go in. So maybe when we're doing long division with polynomials, that's your homework tonight. I have not discussed this at all, but basically we are going to take like this and divide it into a bigger polynomial. All right, so let's do our first example. Let's get rid of the screen. All right. So first of all, set it up. This is A, I believe. Yep. All right. Focus is the easiest process that nobody gets right because they're not focused. Look at that. I'm going to sharpen this so it's more focused. All right. Hey, when you're doing long division, you look at two things. You look at the leading coefficient and the leading coefficient, and that is it. Okay? That's it. Promise me. That's it. Don't look at that negative 3x. Oh, okay. So you ask yourself, x times what gives you x squared? X times what gives you x squared? Well, it's x. So you write an x up there. Okay? Now that you've picked that number, now you multiply it times x minus 4 and write it underneath. Kind of like you pick that 6. Well, you pick the 6, now 6 times 5 is 30, you wrote that underneath. So when we multiply this out, x squared minus 4x, you multiply that times everything. What did we do with the 30? We subtracted it. This is where everybody messes this up. So I'm going to even put it in red here. I put a parentheses around there. I don't go through and change the sign so I can add them. I do that so I can check my work later. And so now I subtract. What should always happen is the first term should drop out. And it does. X squared minus x squared is 0. Negative 3x minus a negative 4x is negative 3x plus 4x, which is x. And then you just pull down the next term. Yep. So x times what gives me x? So now the problem starts over. Now we have x plus 6. So x times what gives me x? That's plus 1. Let's be consistent with our color up here. When we multiply that times that, we get x minus 4. We subtract this. And x minus x is 0. Mission accomplished. 6 minus a negative 4 is 6 plus 4, or 10. We stop. Yeah, we got to stop at some point. We stop when this value, whatever we get, is at least 1 degree less than what we're dividing by. So we're dividing by a linear. This is a constant. We're done. So I prefer writing the result like this. X squared minus 3x plus 6 equals x plus 1, the quotient, times x minus 4, the divisor, plus the remainder. Not very important. Not at all. I would much rather work with this than this. But it's leading us towards something. But I'm not gonna ask you to do too many of these. Here we go. All right, I'm gonna do one more for you, start to finish. X times what gives me 2x squared? 2x squared gives me that. So now I multiply 2x cubed minus 6x squared. I subtract. That goes away, great. That becomes a positive. Positive, so 5x squared minus 13x. That's going to be positive 5x. So I get 5x squared, mission accomplished, minus 15x. I subtract that quantity. Hey, look at that, that works. Negative 13 plus, 2x minus 6, all right. Looks like x, if I do a 2 there, 2x minus 6. Ooh, baby! Yes, little celebration there. That's always good to see when the thing goes in evenly. So, what does that mean to us? That means 2x cubed minus x squared minus 13x minus 6 could be written as x minus 3 times 2x squared plus 5x plus 2. I kind of switched places with that, but multiplication is commutative, meaning AB equals BA, so it doesn't matter. Hey, can we deal with quadratics if we set all this equal to 0? Absolutely. That's a beautiful thing. So maybe if you're really thinking, how in the world would you come up with x minus 3? How would you know that's a factor of that polynomial? Well, there's some tricks, but we're not worried about it. All right, we've got a lot to go here. So there's another example if you want. I kind of color-coded it. Yep, good. So there's a shortcut, okay? Never, ever, ever do long division unless, like, you have to, okay? But you have to do it a few times to kind of get a feel for it. Maybe they give you... Anyways, there's a shortcut way that always works when you divide something by a linear term. A linear term. All right, so we're going to do a quick example. Let's say we take this and we divide it by this. And oh, didn't we just do that? Yeah, so there it is. We know the answer. So look at first, step 1, they do an array. An array is kind of an organizational, and the key is, where do they get these numbers? Where do you think you get 2, 7, 10, 15? All the coefficients. Great. What if they were missing a term like x cubed wasn't there, but they had an x to the 4th? You got to have a 0, placeholder. Be careful. this negative 2, that might have something to do with this. Yeah, because remember, this is in the form of x minus k. So k would have to be a negative 2 to make that work. And basically, nobody remembers negative k. They just say, take the opposite of, here it's positive 2, so you always put a negative 2 there. But there's a reason. Right? All right, the first number here is always 0. Always 0. Okay, that's it. So you're setting yourself up for success. Don't move, don't move. There we go. All right. So the first move is you add the column. You add the column. 2 plus 0 is 2. Great. And then you're going to multiply negative 2 times 2 and put that right here. So that's the negative 4. And you're going to repeat that process over and over and over again until you get to right there. I think this next, yeah, it shows you. So the 2 comes down. Negative 2 is negative 4. 7, negative 4, add them, you get a 3. 3 times negative 2 is negative 6. Add them, 4. 4 times negative 2 is negative 8. Add them, and you get that. Beautiful. Just beautiful. And the crazy thing is this is the thing you just did. Do you notice those numbers are going to be your coefficient of your quotient, and this will always be your remainder. Once you do this 2 or 3 times, it's a piece of cake. So let's do it. All right, so this is the problem that we just did. I'm going to do the synthetic division, and maybe you'll see the numbers, how they appear in the long division. So first thing we do is negative 2. I know we just did this one, but we're just 2, 7, 10, 15. Okay, so you add the 2. I don't write a 0, so sorry. If you want to, you can. I just kind of pull that down. A negative 4, negative 2 times 2 is negative 4. Add them, 3. Multiply negative 6, add them, 4. Negative 8, add them. I like to put a line there, so that's 7. So this is our coefficients of our quotient. And it always starts with x to the 0, x to the first, x squared, x cubed, x to the fourth, as you keep going. So the 4 is always the constant, and that's always the remainder. All right. Yes, we will do another one. So here's the long division of a problem we did earlier. So we would use 2 for x cubed, negative 1 for x squared, negative 13, and negative 6. This is positive 3. Okay, so we pull down the 2, we get a 6. Do we see a 6 anywhere? Yeah, look at that, right there. And a minus is going to give you a positive 6. So when you add these, you get a 5. There's that 5, which tells you what really your next term should be. But so 3 times 5 is 15. Add them. Oh, there's the 15. 2, 6, and 0. So this is cool. We love this. Save that for the next section. Yes. All right. Okay. Division by quadratics. Painful. Very, very painful. We're going to do one together. I really don't. I guess you can't do synthetic division with quadratics. You can do with special ones, you can. But if you're dividing by quadratics and they are being ruthless, this is only one of the only ways you can do it. So I give you an example here. The first thing I'm going to do is make you stop. There is no x cubed term here. So you need to rewrite this and give yourself a placeholder for all these values to line up and stay. You don't have to, but it makes it a lot easier. A lot easier. So I think, yep. So I'm going to walk you through this. It is nothing different from the linear. Look at the leading term and how it works with the leading term as you go. So x squared times what gives me 2x to the fourth? That's 2x squared. And let's see if that works. So if I go 2x squared times everything, I get 2x to the fourth. I get minus 6x cubed. and I get negative 8x squared. I'm going to put parentheses around that and subtract. Yes, that goes away. Beautiful. I get a positive 6x cubed, and I get, I get a plus 5x squared. You see, all the mistakes on this are negative, plus or minus. Everybody can do it, but it's tough to get the plus and minuses. So now I'm looking at 6x cubed and x squared. So that's going to be positive 6x. Let's just check it. 6x cubed, yes. Minus 18x squared minus 24x. Oh, sorry. We got to bring down that x. So bring down that next term. So we subtract that quantity. Hey, that went away good. 23x squared plus 25x. It's not the same answer I got when I did this as a warm-up just a second ago. So it just goes to show you, I'll make mistakes too on this. But I think I'm right. So that's good. 23x. No, 23. So that's going to give me 23x squared minus 69x minus 92. And when we subtract that quantity, we're going to get 94x plus 85. That's our remainder because it is 1 degree less. Woo! That's funny. I was going to give you like 2 more sections. I'm going to stop. I think that's enough. Let me be very clear. This is a lot of quadratics. Do them until you think you've got it. If you at least 2. Do at least 2. Do at least 2. Okay? Greater than equal to 2 problems. I think once you do it once or twice and you got it, I think you're all right. So that might be a little bit. And you are welcome to use synthetic division wherever possible. Hey, do 1 or 2 long division just to get the feel, but you're good. I would say these are the ones. These are the IB ones. Those are the ones you really want to pay attention to. Hey, thanks for playing. Have a great Friday. Have a great. I will give you one more video to watch before Monday. It's going to be awesome. Thanks.